The sum of the first three terms of a convergent infinite geometric series is 19. The sum of the series is 27. Find the first term and the common ratios. Quite a lot of information in there, but it tells you it's convergent and it tells you it's an infinite series. So any convergent geometric series, you know that this absolute value of r is less than 1, because that's what means that for bigger values of n, new terms are so small, so close to 0, that they don't make a difference. So they don't make a difference to the sum, as in adding up all the numbers. So we need to get our formulas. So you know that Sn, as in the partial sum, could be written as u1 times 1 minus r to the n over 1 minus r. So as I was saying, for convergent infinite series, as n gets really large, r to the power n basically gets towards 0. So what that means is 1 minus r to the n just becomes 1. So this whole term, this sum to infinity, is everything apart from this is just 1, so you can just cancel that. So the sum to infinity, which, as I keep saying, only applies when you have this r is less than 1 or it's negative. It's between 1 and 0, so something like 0.4 or something like minus 0.3, something like that. But anything bigger than 1 or a negative number smaller than minus 1, you can't apply the sum to infinity formulas. So it's just u1 over 1 minus r. Okay, so what do we know? So I'm going to probably start with this 27. So if I know that the sum of the series, so the total sum of the series, which must be the sum to infinity, because it tells me it's an infinite series, so it doesn't need to tell me n, because for bigger values of n, the terms that they're so small that they don't matter anyway. So I know that u1 over 1 minus r equals 27. So that's the first bit. Now we'll deal with this sum of the first three terms. So the sum of the first three terms is 19. So that's a partial sum, so I'm going to use the partial sum formula here. So S3 equals u1, 1 minus r to the n, well n must be 3, r cubed, 1 minus r cubed, over 1 minus r, and that must be equal to 19. So what I'm going to do, I want to find a way to use this 27 to make this a lot more manageable, so I can solve something. So if you look in here, you've got a u1 over 1 minus r, and you can see u1 over 1 minus r here. So if I kind of just pull this fraction apart a bit, I can probably write this as a u1 over 1 minus r, and I can make a substitution. So I'm going to rewrite this s3 over here. So s3, I'm going to say, well, that's u1 over 1 minus r times 1 minus r cubed. And I'm going to say that is 19. Right, so it's exactly the same thing. I've just kind of pulled it apart. If I was to multiply this together, put it back again, it would look exactly the same. So now I can make this substitution. So sub in u1 over 1 minus r equals 27. So that means that 27 times 1 minus r cubed times 1 minus r cubed must equal 19. So now we're starting to get an equation with only one variable, and I only actually want to find the common ratios. Once I find out, I'm finished. So I am going to expand this bracket. So 27 minus 27 r cubed equals 19. Now remember, we're not going to find r, so I'm going to try and make r the subject to this. I don't want to be messing about with negatives. So I'm going to move this minus 27 and r cubed over here. So add 27 r cubed to both sides. And I'm going to get the 19 over here, subtract 19 from both sides. So 27 minus 19 equals 27 r cubed. Well, 27 minus 19 is 8, so 8 equals 27 r cubed. If I divide both sides by 27, 8 over 27 equals r cubed, which you should notice is a very nice cube numbers. So r, if r cubed is that, well, r must be the cube root of all of that, 8 over 27, and hopefully you know that the cube root of 8 over 27 is the cube root of 8 over the cube root of 27. The cube root of 8 is 2. Cube root of 27 is 3, so r must equal 2 over 3.